Hi, so we're going to pick up with the classification of epithelia now. So recall that I will highlight slides as a cue for you to understand the content because this specific content will show up on your exam. A simple squamous is a one-layer scale-like thin and delicate cell. It's adapted for the ease of diffusion. So here we can see it in the air sacs of the lungs, right? And if you imagine that oxygen needs to diffuse in and out of the blood, right? So for use in the lung tissue, then you have a single layer, and that is that form allows the function to function smoothly. Cuboidal epithelium, one layer because it's simple, cube shaped because of the shape, and usually involved in secretion and absorption. They form the walls of the smallest ducts of glands and many of the kidney tubules. Right? So here we have a microscopic image of a cuboidal cell of epithelial tissue, right? And you can see how you have a simple cell here with the nucleus, and it looks cube-like. Okay. Simple columnar, one layer, elongated, closely packed cells, typically. Some will have the microvilli, which are those hair-like projections to take things in. Some have cilia to move things out, so the hair-like projections that move things out. And there's also some goblet cells, which secrete mucus that can be located in this type of epithelia. We see this in the digestive tract, right? So if you can put together digestive tract, would that be microvilla? Or cilia, microvilli or cilia, right? So absorption, digestive is going to pull nutrients in, and it would be, so that would be the microvilli. Here's a cartoon of the simple columnar, right? Very long, a long cell. Pseudostratified, falsely stratified, located in the upper respiratory tract, some ducts of large glands and tubules in the testes. So these contain the microvilli as well. Many do, or they can be ciliated. So the location is, whoa, is that a double slide, guys? Anyway, we got the location twice. Moving forward quickly. So I love this because cigarette smokers tend to destroy the ciliary ladder, which moves mucus out of the lungs. So you get that dry smoker's cough, like they can't seem to get the whatever's caught in their lungs extracted. Keep trying to move it, but the damage to the cilia, which is literally burned off by the smoke, it prevents you from allowing to clear that mucus away easily. You could have damage from a fire incident, right, where you were in a room and had to inhale smoke, right, in a big way. That could be a long-term effect from a unexpected event in someone's life where they were never a cigarette smoker but end up with damage in that way. Okay, so pseudostratified. Here's a nice picture of it. There's a goblet cell that would secrete mucus located here. And then this is the sweeping that the mucus would come out, right? And then this would sweep it up and away. Again, it's tacked down. So it's that one cell here is tacked down to the connective tissue. That's why it's a single layer, and it's pseudostratified because just a cursory glance, you might not recognize that these cells are just tacked down there, and you think it's multiple layer. Okay, if it's anything, if it's stratified as 2 or more, the new cells will generate from below and then slough off or be removed at the apical surface. They're more durable because they need to be for their function, so they'll have characteristics within the cells that make them more durable. There's a free surface is squamous with deeper cuboidal cells or columnar layers located in areas of high wear and tear. So again, for protection, you're going to have the stratified squamous epithelium, and there's keratinization happening here, which we'll look at in depth in the integument, but keratinization is like a hardening of a cell, and that gives it its protective characteristics. So here we see it here on the microscopic level. And stratified squamous cells protect the underlying tissue. So this becomes a protective border. Can you imagine if you needed to protect something underneath this and you only had a single layer? That wouldn't be enough, right? So even just having multiple layers allows for more protection, as well as what is happening in the cellular layer, right? If you have the hardening, something that's making it stiffer, more that will prevent things from coming in and things from coming out. Transitional epithelium, here's a nice image of the bladder, right? And these cells will look cuboidal, but then when that bladder fills, they'll appear squamous. So the ability of these cells to change shape when stretched is what makes them a transitional epithelium. Okay, we've got a microscopic view of it here. And this is the basement membrane, right? Adhered to connective tissue. And here's the apical layer. So again, the main functions of all epithelial tissues are to protect, absorb, to be a filter, to excrete, secrete, and do sensory reception, take information in. So not each one does all of these, but all of these do one of these at least. Okay. What happens with cancer? So with cancer, the epithelial cells, they invade the basement membrane, so they don't stay where they're supposed to be. So they go into the underlying tissue, and that's how cancer spreads. Squamous cell carcinoma and basal cell carcinoma. So these two don't invade the basement membrane when we look at skin cancer. Again, in more detail coming up, but I want you to know that these cancers are not as likely as the other carcinomas or cancers to invade the basement membrane. So we'll look at the ones that do, but these ones, if you were diagnosed with a squamous or a basal cell carcinoma, it would likely be able to be treated by excisation, so just taking it out and away, and you'll be fine. So those are the least malignant or the least dangerous of the skin cancers, and specifically here. This is an example of the cancer of the cervical cancer of the uterus, cervical cancer, and it's no laughing matter. But what I'm laughing at is my ability to find words in my brain and then tell them to you. So anyway, we've got it, and this is what I like about this, and why I'm showing it to you as an example now is because basically the DNA in one of these cells is off. Okay, now there can be genetic reasons that there's a DNA mutation. There can be environmental reasons, right? So when we talk about not eating processed food or exposing ourselves to too much sun, right? Those are all environmental things that can have an effect on the integrity of the DNA of the cell. So what happens is the DNA gets wonky. It doesn't follow its normal pattern anymore for whatever reason, and it does an unstoppable proliferation, right? So these cells here, they have a DNA program that's like, okay, I'll produce this many cells, I'll die at this time, and I'll have a whole cell life and death circle that will allow for the organism to function, right? So at the molecular level, the cell functions well. At the tissue level, the tissue functions properly, and then the organism functions properly at the macro level. All right, so normal cell, cancerous ones, it doesn't happen that way. It starts to proliferate at an abnormal rate, right? And it starts to, so because it's proliferating at an abnormal rate, it is pushing into the basement membrane. So when you find cancer in the epithelial tissue, right? Again, this is a nice stage to find it at if you can extract it and remove it from the system, because the cells by it start to become cancerous as well and copy that pattern and start to make more cancerous cells until you have this this effect. So now they start stacking up. We're getting more and more cancerous cells, and it's got more force, more physical force to exert on the connective tissue. And now the connective tissue can't withstand that, and the membrane is broken, and this starts to invade the connective tissue, and now you have the cancerous cells able to spread down into the connective tissue layer, which then can eventually become systematic, which is why we try to do an intervention with cancer cells as early as possible. It's why we have a lot of screenings too, because the earlier this can be detected, the less the cancerous cells will invade healthy tissue, and the better the prognosis. Let's pause here.